During this lab, we will see how to create a simple MCC project. We are going to use MPLABX IDE version 5.35 for software development as visible on the screen, and ATtiny817 explain board as a hardware. It's a low-cost development board. Explain board contains onboard programmer and debugger. Provides connectivity to your PC by micro USB connector. The whole board is provided power by the same USB power connection. Other than that, the board contains one LED and switch for input. We can configure GPIO connected with LED in output mode and switch pin in input mode, so that when switch is pressed, LED should go on and off when switch is released. So now let us create a new project. Click the File tab in upper left bar, then select New Project. On this window, we see various options which are self-explanatory. Choose Standalone Project option now, then Next. Here we will enter the part number 817 and we'll see the full part number, that is ATtiny817 we are going to use. Select that and then click Next. On this window, we can select the programmer or development kit what we are going to use. We can leave it blank or unselected, or can select any connected kit with our PC. So right now I am going to select kit 4 for example, and then Next. On this window, we see the compiler options installed on my PC. So right now two compiler versions are installed on my PC, that is XE8 2.00 and XE8 V1.45. So 1.45 is not highlighted. That means this version of compiler is not supported for this particular microcontroller part number. So let's select V2.00, then click Next. Here we will give the project name. Let's give it name test project ATtiny817. So here we can select the project location. Set as main project is checked, then click Next. Finish. So our project is created. We can see that in project panel on left side of the screen, we can see various folders inside project. Try to explore each. No source file. Now we can use MCC to generate all necessary source and header files, including MCU peripheral initialization code and various software stack etc. To start MCC, we can click blue MCC symbol on toolbar or go to Tools, Embedded, Then select Microchip Code Configurator. Just click. The first thing MCC will ask you to save one .mc3 file. This MC3 file will contain all MCC configuration for the project made by us. Its default location is the project folder, so we need not to change anything here. Just click Save button. Now we can see a new tab, Resource Management, added to project panel in the top left side. While Resource Management selected, we can see project resources, device resources, which includes all resources available with the selected microcontrollers, and the lower window versions. We can see MCC version and the libraries installed in our system. On the right side, you can see MCU package, all pins properly marked and in different colors based on their availability. And on lower side, we can see the pin manager window where we can assign function to each GPIO. Okay, let's go back to project resources. Under the system, we can see three modules: interrupt manager, pin module, and system module, which can be configured separately. Let's go to system module first. It contains all the settings related to system like clock source, watchdog timer, and BOD related settings. By using drop down menus, we can select required parameter settings like clock source and speed, watchdog time, BOD voltage level, and interrupt. Okay, let's go back to project resources. Under the system, we see interrupt manager, pin manager, system modules, which can be configured separately. Let's click system module first. It contains settings related to clock source, watchdog timer, BOD, brownout detect. By using respective drop-down menus, parameters can be configured. Similarly, pin module contains setting related to each GPIO. That is, function or role can be assigned to each GPIO. Interrupt manager contains core related interrupt settings. Okay, let us configure the GPIOs according to LED and switch connected to explain board. LED connected at PC0 and switch connected at C5. Under the pin module settings, you see all unlock symbols inside a light blue color box. That means all the pins are unassigned yet and are available. So now we want to assign C0 in output mode for LED control. So under the port C, that is the 0 in the row output, click here, you will see the green box become green and the symbol with logged. That means the particular pin has been assigned for output. Similarly, for switch, we will assign C0 in C5 in input mode. This one. After the setting, you see these two pins, the same two GPIOs we configured now are ready to above window and have other related settings also for configuration, like the custom name, default output level, interrupt enable, etc. In the right side package view window, you can see two GPIOs has become green. That means these two pins are in use now. Similarly, for demo purpose, we can see how other peripherals can be added to the project. Let us take timer 0 example. In the device resources, go to TCA and click on a small triangle left to it. Click on green plus symbol to add this resource to pack project resource. Okay. So timer 0 has been added to project resources, and on the right side related settings are open to be configured. So here we can select all related settings like clock selection, timer mode in 8-bit or 16-bit mode, enable, disable, interrupt, like that. Now for generating C code for all selected resources, click the generate button next to project resources. Automatically all respective C and H files get generated and list can be seen in output window. So here you can see generation complete and list of generated C and H files is here. Let's click project tab to view generated code, that is C and H files in project. Now you can see some folders added to our project. On exploring source files, main.c is created, and inside the same folder MCC generated files folder is there, which includes all other newly generated files added. Similarly, following same file structure, all header files added to the folder header files. Inside source files folder, two more files are visible, that is device config.c, which contains configuration or fuse bit settings, and MCC.c contains system initialization functions. Inside src folder, all peripheral related C files added. If you go to main.c, main function is created and system initialize routine call is already added. Here we can write our application code. On navigating the system initialize function, for that we press and hold control and click on this highlighted function. It will take us to the function body. Here we can see all pin manager initialize, BOD initialize, watchdog timer, clock control, timer A, CPU initialize related APIs are being called. So let us see building the project. For that we need to click on this hammer with brush, which will clear all object files and build the project. So project is built successful. Just ignore this warning. So now let us add some our custom code for controlling the LED based on switch status. So okay, go to the while loop. So in if condition, here we are just checking whether this particular pin where switch is connected is high or low. Based on that, we are making port C.out register the particular pin C0 high, and if switch is not pressed, then making the C0 as low. So we have initialized timer 0 also, and its interrupt. So let us see where its ISR is placed. Inside src folder, there is a file tca0.c. So here we see tca0 default overflow interrupt ISR callback function. So here we can write our any piece of code, something like to toggle the LED. If not using the same LED in main routine, then we can test it here also. Okay, let us try building the project once again. So build successful. For now we are commenting this line of code. So till now we have seen how to configure a project and generate MCU peripheral initialization code by using MCC. Also, we configured one pin as an input to read switch input and another pin as output to drive the LED. We also configured timer 0 to see initialization method and its related interrupt service routine location, where we can add our customized code. Now, after completing the software part, to see the result on development board, let us connect the board to PC through USB cable. For checking the programming tool selection and settings, right click the project name and click properties. In the next visible window, after scroll down, you can see available tools and programmers connected with your PC. Select right tool and then click apply and then OK. After that, for programming the MCU, click the green down arrow button on toolbar. Once programming is successful, you can see the result in output window. And now see the demo code running on explain board. And you can see the demo is working as expected. And second demo, after configuring the timer 0 overflow time to 500 millisecond, let us program the microcontroller once again. Programming is complete. Let us see the result on board. LED is toggling inside the timer ISR at the rate of 1 Hz. Thank you.